Do you have any question?
No, hocam, we can start.
Do you see these slides, I think?
Yes, sir.
Okay, vector error correction. I'm going to introduce you the VAR model. I don't know if you ever studied or exercised this model. A VAR model can be presented either in restricted form or in unrestricted form. Restricted form is the vector error correction, and unrestricted form is the VAR model. Today we will exercise the vector error correction. I will give you some information about the VAR model, and then go through to the model, how to interpret and how to perform this test, the VAL test, so-called the all applications, the Johansen co-integration. Everything will be introduced to you. Vector autoregressive integrated model comprises multiple time series and is quite a useful tool for forecasting. It can be considered as an extension of the autoregressive model, so-called the ARIMA. Let me check because my pointer is not working. That's fine. Okay. VAR model involves multiple independent variables and therefore has more than one equations. Each equation uses as it is explanatory variables, lacks of all the variables and likely a deterministic trend. Time series models for VAR are usually based on applying VAR to stationary series with first differences to original series, and because of that, there is always a possibility of loss of information about the relationship among integrated series. Differencing the series to make them stationary is one solution, but at the cost of ignoring possible important long-run relationship between the levels. A better solution is to test whether the levels regression are transferred, so-called the co-integration. The usual approach is the Johansen's method for testing whether or not co-integration exists. If the answer is yes, then vector error correction model, which combines levels and differences, can estimate it instead of VAR in levels. So we shall check if vector error correction model is being able to outperform VAR for the series we have. How to determine restricted VAR, so-called vector error correction, or the unrestricted VAR. If all variables converted to the first difference, then they become stationary integrated in same order. The null hypothesis is the variables are stationary, and alternative hypothesis variables are not stationary. If the variables are co-integrated and have long-run association, then we run restricted VAR, so-called the vector error correction. But if the variables are not co-integrated, we cannot run vector error correction. Rather, we run unrestricted VAR. So what is the differences between VAR and the vector error correction model is also important to know before performing this test. Through vector error correction, we can interpret long-term and short-term equations. We need to determine the number of co-integrating relations. The advantage of vector error correction model over VAR is that the resulting VAR from vector error correction representation has more efficient coefficient estimates. When to use VAR or the vector error correction, you should use vector error correction model if your variables are non-stationary and you find a common trend between the variables, so-called the co-integration. Unrestricted VAR, after performing co-integration test, results will show following estimations. The trace statistics will become lesser than the trace critical value. Null hypothesis, there is no co-integration, and alternative hypothesis, there is co-integration. And when the trace statistics is less than test critical value, we cannot reject null hypothesis. There is no co-integration, and the probability values are more than 0.05, which these all gives us sufficient information about performing the unrestricted VAR, so-called the vector error correction model. So sorry, VAR model. I wrong. Restricted VAR or vector error correction. After performing co-integration test results, will shows following estimations. Trace statistics will become higher than the test critical values. The null hypothesis is then there is no co-integration, and the alternative there is co-integration. And when the trace statistic is more than test critical value, we can reject the null hypothesis. There is co-integration. The probability values now then become less than 0.05, which will use then restricted VAR, the vector error correction. According to Engel and Granger, in 1987, two I1 series are said to be co-integrated if there is an existence of some linear combination of the two which produce a stationary trend at I0. Any non-stationary series that are co-integrated may diverge into the short run, but they must be linked together into the long run. Moreover, it has been proven by Engel and Granger in 1987 that if a set of series are co-integrated, there are always existence generating mechanism called error correction model, which forces the variables to move closely together over time, while allowing wide range of short-run dynamics. When we are going to introduce the model, the basics of the vector autoregressive model, we lay the foundation for getting started with the crucial multivariate time series model and cover the important details, including what a VAR model is, who uses VAR models, basic types of the VAR models, and how to specify a VAR model, estimation and forecasting with the VAR models. To determine whether VAR models in levels is possible or not, we need to transform VAR model into levels to a vector error correction model in differences with error correction terms to which the Johansen test for co-integration is applied. In other words, we take the following 4 steps. First, we construct a vector error correction model in differences with error correction terms. In the second, we apply the Johansen test to the vector error correction model in differences to find out the model number of co-integration, so-called the R, none or at most. And if R is equal to 0, we will then estimate VAR in differences. And if R is becoming more than 0, then estimate vector error correction model in differences of VAR in levels. At least one co-integration equation will then available. Its identification depends on the number of co-integration in the following way. None, so-called 0, R is equal to 0, there is no co-integration. In the case of no co-integration, since all variables are non-stationary in level, the above vector error correction model reduces to a VAR model with growth variables, at most 1, R is equal to 1 co-integration vector, and at most 2, R is equal to so-called R is equal to 2 co-integration vectors is supposed to be available, and at most 3, R is equal to 3, then full co-integration is supposed to be realized. In the case of full co-integration, since all variables are stationary, the above vector error correction model reduces to a VAR model with level variables. Johansen test for the co-integration, the rank equals the number of its non-zero eigenvalues, and the Johansen test provides inference on these numbers. There are 2 tests for the number of co-integration relationship. The first test is the trace test, whose test statistic is H0. Co-integrating vectors is less than R or equal to R, or H1, so-called the alternative. Co-integrating vectors becomes larger than or more than R plus 1. The second test is the maximum eigenvalue test, whose test statistics is given by H0 there are R co-integrating vectors, and H1 there are R plus 1 co-integrating vectors. The restricted VAR, so-called the vector error correction model, assess the selection of the optimal lag length in a VAR, evaluate the use of the impulse response functions with a VAR, and assess the impulse response variation on the standard VAR, and critically appraise the use of the VARs with financial models and assess the use of the vector error corrections. Let's start with the restricted VAR. The vector error correction model, what was the guideline? After performing the co-integration test results, we will show following estimations. As I said to you, trace statistics will become higher than the test critical value. The null hypothesis, there is no co-integration, and the alternative hypothesis, there is co-integration. And when the trace statistics is more than trace critical value, we can reject null hypothesis, there is co-integration, and the probability value are less than 0.05. How to do the estimation, multivariate, co-integration, and the vector error correction models. Now we are going to introduce you the step-by-step how to do the test. The test, the variables for station are using the usual augmented Dickey-Fuller test. If all the variables are in I1, so-called the inverse difference, include in the co-integrating relationship, use the Akeike info criteria or Schwarz info criteria to determine the number of lags in the co-integration test, order of the VAR, use the trace and maximum eigenvalue test to determine the number of co-integrating vectors in presence, and when the trace statistics is more than test critical value, we we can reject null hypothesis. There is at least one co-integration equation, and our variables have long-run association. In the long run, they move together, is supposed to be. And after this, then this all implies we can run restricted VAR, so-called the vector error correction, because trace statistics and the maximum eigenvalue statistics values are more than test critical value, and there is at least one co-integration equation. We reject the null hypothesis, and the probability values are less than 0.05. In opposite case, we run the unrestricted VAR, as I mentioned to you. We perform and estimate the table for the vector error correction after this model, and then find the equations for our model. From these equations, we derive the residuals for co-integration equation for dependent variables. We use the least square method to find the long-run effects on variables. And first coefficients of this least square table indicates the speed of adjustment either towards or move away from the equilibrium in the long run, and negative coefficients is good, and it is the indication that the whole system will bring back to the equilibrium, and the p-value must be less than 0.05 for the significance, and t-value, if it is greater than 2, it is significant, so-called the t-statistic. Then after we perform the Wald test, Wald test for short-run causality from OLS, or ordinary least square table, we got the coefficient diagnostic for performing the Wald test. We use following null hypothesis equation for performing the Wald test, so-called C3, the equations that we are obtaining from this dependent and independent variables. The C3, suppose we are giving here 3 and C4 is equal to 0, then we will then estimate for the Wald test of these two variables and coefficients, p-value must be less than 0.05 for the significance. What is Wald test? Wald test statistic explains the short-run causality between variables, while the statistics provided by the lagged error correction terms explain the intensity of the long-run causality effects. Short-run Granger causality are determined by the Wald test statistics for the significance of the coefficients of the series. Vector error correction model are the basic VAR with an error correction term incorporated into the model, and as with bivariate co-integration, multivariate co-integration implies an appropriate vector error correction can be performed. The reason for the error correction term is the same as with the standard error correction model. It measures any movement away from the long-run equilibrium. These are often used as a part of the multivariate test for co-integration. such as the Johansen test, having found evidence of the co-integration of some I1 variables, we can then assess the short run and potentially Granger causality with the vector error correction model. The finding that many macro time series may contain a unit root has spurred the development of the theory of non-stationary time series analysis. Engel and Granger in 1987 pointed out that a linear combination of two or more non-stationary series may be stationary if such a stationary or I0 linear combination exists. The non-stationary with a unit root time series are said to be co-integrated. Here we are not talking about the series that we are transforming and taking into the first difference. We are taking the raw material, the raw data that we are already doing the unit root and then transforming it to the first difference and controlling whether it is in the stationary or not stationary. We are talking about the raw material here, raw data here. And as you see, raw data is important to transfer to the first difference for being able to estimate its stationary or non-stationary in the model. You can perform this with this given EView data, but it is better to transfer it to the first difference and then employ this, because this will then give you more reliable estimation, because you are going to use the I1 data for your vector error correction. And if you are not going to control its stationarity, it will be a problem probably in the estimation. The stationarity linear combination is called the co-integrating equation and may be interpreted as a long-run equilibrium relation between the variables. For example, consumption and income are likely to be co-integrated. If they were not, then in the long run, consumption might drift above or below income, so that consumers were irrationally spending or piling up savings. That's the reason, because if you know some economics, the marginal propensity of saving and marginal propensity of consumption is equal to 1. And if you have $1, amount of this dollar is supposed to be divided into pieces, and the one pieces will be distributed to the consumption and the rest will be going to the saving. Therefore, it is important to know what is happening between the consumption and saving. In these regards, then we will then evaluate and will be able to determine the disposable income estimation. A vector error correction model is a restricted VAR that has co-integration restrictions built into the specification so that it is designed for use with non-stationary series that are known to be co-integrated. The vector error correction specification restricts the long-run behavior of the endogenous variable to converge to their co-integrating relationship while allowing a wide range of short-run dynamics. The co-integration term is known as the error correction term, since the deviation from the long-run equilibrium is corrected gradually through a series of partial short-run adjustments. The vector error corrections model or the estimation are the basic VAR with an error correction term incorporated into the model. The reason for the error correction term is the same as with the standard error correction model. It measures any movement away from the long-run equilibrium, and these are often used as a part of multivariate tests for co-integration, such as the Johansen maximum likelihood test. The vector error correction model, however, there are a number of differing approaches to the modeling vector error corrections. Correction models. For instance, how many lags should there be on the error correction term? Usually just one, regardless of the order of the VAR, and the error correction term becomes more difficult to interpret as it is not obvious which variables it affects following a shock. Do you have any question up to now? Do you have any problem with this presentation?
Not yet, sir. No, no, sir.
Okay. Okay. Good and true. The model is given, as you see, we are taking the first difference, therefore we are having the data's first difference. The delta is the differentiation, x then the dependent, then we have the x1, x2, it goes like this, and y, z, it goes to the epsilon and the error term in the equation given. This is the basic vector error correction for given model. Vector error correction, first we test if the variables are stationary, which means I0. If not, they are assumed to have a unit root and are I1. If a set of variables are all I1, they should not be estimated using OLS, as there may be one or more long-run equilibrium relationship. The cointegration, we can estimate how many cointegration vectors exist between variables using the Johansen technique. The vector error correction, if a set of variables is found to have one or more cointegration vectors, a suitable estimation technique is a vector error correction model that adjusts for both short-term changes in the variable and deviations from equilibrium. The Granger causality tests whether a variable is helpful for forecasting the behavior of another variable. It's important to note that Granger causality only allows use to make inference about forecasting capabilities, not about true causality. The Granger causality statistic, as we previously discussed, Granger causality statistic tests whether one variable is statistically significant when predicting another variable. The Granger causality statistics are F statistics that test if the coefficients of all log of a variable are jointly equal to 0 in the equation for another variable. As the p-value of the F statistic decreases, evidence that a variable is relevant for predict another variable increases. The Granger causality tests were used when the variables are cointegrated. The Engel and Granger 1987 warned that if the variables are stationary after first differencing in the existence of cointegration, the application of VAR to the analysis will be spurious. The outcome of the stationarity test using ADF revealed that our variables are I1. For example, in the Granger causality test of x on y, if the p-values is 0.02, we would say that x does not help predict y at the 5% level. However, if the p-value is 0.3, we will say that there is no evidence that x helps predict y. Therefore, Granger causality is always expected to have when the p-value is somehow less than 0.05. Impulse response and variance decomposition also important in this aspect for estimating the vector error correction. The impulse response are the relevant tools for interpreting the relationship between the variables, and the variance decompositions examine how important each of the shocks is a component of the overall unpredictable variance of each of the variable over time. Impulse response function is given here for the inflation and for the output to inflation and inflation to inflation. As it is given, it is somehow it is decreasing and coming to the approaching to the 0 at 20, and it comes somehow stationary, a little bit decreasing and increasing regarding to the stagnation of the inflation in the period. And from output to inflation, as you see, the impulse response is somehow moving from negative to positive, and in the left side it is moving from positive to negative, which is going to be explained in the graph also, in the table also to you, for being able to understand how it is affecting the impulse response, the parameters in the response. The impulse response function traces the dynamic path of variable in the system to shocks to other variable in the system. This is done by estimating the VAR model, implementing a 1 unit increase in the error of one of the variable in the model while holding the other errors equal to 0, and predicting the impacts H period ahead of the error shock and plotting the forecasting impacts along with the one standard deviation confidence intervals. Impulse response sample estimation and interpretation is given here for just only one variable because we don't have sufficient places to put all the explanatory variables here to see how it is affecting and changing the variables. The result shows here, as I said to you, given for just only inflation, so-called the consumer price index. And as on the table seen, the variables, the red colored, the nominal interest rate has positive response to the CPI, to the consumer price index. And as you see, the other variables have negative values, and this is then negatively affecting and responding to the nominal interest rate. Regarding to the nominal interest rate, because nominal interest rate have a positive impact to the, because there is only one the negative, and the other variables, when we are looking, there are more than one, there's three, four more than three variables which is affecting and changing, numbers which is affecting and changing the consumer price index. Therefore, real effective exchange rate and consumer price index affecting negatively the GDP affecting negatively the CPI, and only the nominal interest rate is affecting has positive impact on affects positively the CPI. If you have any question, you will ask, and I have already give you the guideline. The impulse response positive values have positive, negative values have negative effects on the dependent here. As you see, dependent here is considered as CPI. Therefore, this is important to know that you are going to look the numbers, positive and negative signs, as I have illustrated on the graph here. The direction of the impact and the affection is given here. Inflation to inflation is, as you see, comes from positive to negative, and output to inflation, it is somehow is a little bit coming from positive and goes to negative, and mostly output negatively affects the inflation. And when we are looking at the variance decomposition, estimation, and the interpretation, this is also important to know. On the graph, there are bold written numbers, the real GDP and the real effective exchange rate. These are estimations of one of my paper. On the table, the variance decomposition results is given for CPI again, and the real GDP and the real effective exchange rate affect the CPI more than the nominal interest rate. Why it is so? Because they have more and higher numbers comparing to the nominal interest rate. As you see, real GDP has got 11,000 something, 21, 23, 24, 25. It goes like this. And when you go to the nominal interest rate, it is only 1 point something, 1.3, 1.5, 1.6, 1.7. It is not huge and higher and bigger numbers, which is affecting and changing the CPI. And when we go to the real effective exchange rate, similarly, it is comparing to the nominal interest rate. There is higher and more impact to the CPI, so-called the consumer price index. If you have any question, you will ask. Forecast error decomposition separates the forecast error variation into proportion attributed to each variable in the model. Intuitively, this measure helps users judge how much of an impact one variable has on another variable in the VAR model, and how intervened on variable dynamics are. For example, if X is responsible for 85% of the forecast error variance of Y, it is explaining a larger amount of the forecast variation in X. And however, if X is only responsible for 20% of the forecast error variance of Y, much of the forecast error variance of Y is left unexplained by the X. Therefore, as you see, if it is smaller percentage, there is unexplained by X. And if it is higher, let's say here 80% and more than 80% is explaining a larger amount of the forecast variation in X is subjected for the forecast error decomposition. And here is also given for the inflation. As you see, if it is above, there is somehow positive effect and highly impact to the inflation is indicated or the indications. And if it is below, which is going down, as you see, the higher and enlarged numbers is the indication of the considerable impact and affection to the inflation. How to identify possible structural shocks. As you see, structural breaks and structural shocks becomes also a problem in the estimations, and we are questioning only shortly because this is not our subject, but for just to bring into attention to you, shocks in the run in this vector error correction is important for the long run restrictions. The sign is also important for these estimations. And if we are going to consider, for example, the exchange rate, so-called the exchange rate, shocks from flexible to pegged. Flexible to pegged meaning you know, if there is a flexible system, if the exchange rate, the foreign currency is let it to stagnate by the market, by the changes of the variables, and so it's the currencies is the flexible. And if it is pegged, if you are fixing your currency to a certain, let's say, in 2000, I think 15 was it. It was pegged. The UK pound was fixed around six Turkish lira. £1 was around 1.8 something, like I don't remember exactly, was fixed, which is pegged to the system, and it is not letting to stagnate and deviate and flexibly affected from the real changes, and the real estimation of the domestic currency is then not allowed. And due to this reason, exchange rate shocks from flexible to pegged should increase crisis probability. As I mentioned to you, if it is pegged, this is also affecting the system because you don't know exact estimation or impact of the foreign currency into your economy or into your currency. And if it is flexible, then it is also, as you are exercising currently, our currency is very highly stagnating and becoming very huge fluctuation regarding to the foreign currencies, to the euro, to the US dollar, to the UK pound. It is very highly stagnating and depreciating, and results of this, our currency become very depreciated and very weak currency. It is not very valued currency in the international market, and it is not desired. Even if it is convertible to the international market, no one wants to use Turkish lira probably because it is very cheap and very depreciated currency as naira, as other emerging economies currency. Unfortunately, we are not able to use our currencies when we are trading or when we are having some transactions from foreign countries or foreign traders. And capital account liberalization shock from less to more free capital flows should increase crisis probability. As I mentioned to you, this is also important. The capital shocks when you are having problem in the resources in the financial sector, this is also affecting and changing the economical structure. And the crisis always happened when you have financial problem or inabilities or insufficiencies, and your currency becoming very deep and very depreciated against to foreign currencies. And these are the indication that the crisis is coming, and the demand is becoming recessionary and reduced and going to the left, and this will then cause too much to the economy. And what effects is expected to the output or the Y, or so-called the production, is probably it is expected to reduce the output. It is expected to reduce the GDP. Therefore, this is not good for the economy. You have to have your currency reliable and very strong, and you have to have your financial system with a reasonable saving ability around 15% to 20%, maybe 25%, which is very high. Then this will then maintain structural reliability and structural platform for stable and very strong economical structure. When we are comparing or discussing the vector error correction as a conclusion, as a concluding remarks, we may say some short information, so some brief information about the model. The vector error correction allows us to obtain jointly the long run or long-term and short-term relationship between the variables. As you know, the co-integration equation will give you information about the long run, and the Wald test results will give you the impact on the short run effects. The vector error correction model will be correctly specified, and the interpretation of the results are simply yet intuitive. And vector error correction model allows us to deal with the both stationary and non-stationary variables with different orders of integration, which is mostly the vector error correction are taken for the I1, sorry. And vector error correction model allows us to examine the serial correlation, functional form, normality, and heteroscedasticity. And vector error correction model allows us to find the first difference variables and error correction term, which is the direction of the, let's say, correction towards to the equilibrium if it is negative sign, and if it is positive, then it is moving away from the origin to the equilibrium. The advantages of the vector error correction model and over the VAR model is that the resulting VAR from vector error correction model representation has more efficient coefficient estimations, and we can conduct only for the series which are stationary in their differences at I1, and there is much debate on how the log length should be determined. It is possible to end up with a model including numerous explanatory variables with different signs, which has implications for degrees of freedom. Okay, then this was the presentation for today. If you have any question, you will ask me. If you don't have any question, then next week, then I will present you the unrestricted VAR, and then after this, then I will perform you this vector error correction in the E-view. Then we will then finalize probably our period, our semester with your performance in the E-view. You will then do one more application regarding to these models, and then we will go to the final exam. If you have any question, please let me know. If you don't have any question, then see you next week.
Hocam, can you upload it to queues or in this?
Yes. PowerPoints, yes.
Yes, thank you.
PowerPoints. I will upload, and I will upload the video also to the YouTube. Then you can watch it also there.
Yes.
I will then give you more comprehensive some PDF documents for the VAR model. Then you will then read also there if you are interested to get more detailed information about this topic.
Yes.
Today you are not all here. I hope next week you will be able to join the class regularly. If you have any question, then you may communicate with me either email or you may come to my office. Thank you for joining this class, and see you next week then. Okay, bye-bye.
Have a nice.
Good evening, sir. Bye-bye.
Bye-bye. Bye-bye.
Bye, sir.